Hello folks, I'm going to do a couple of videos here for this lesson. They're two different documents, so there'll be two different relatively short videos, I think. And I'm not going to do all the problems here in the video. I will post the solutions in a separate solution document, but I'll certainly go through some of the problems and some of the more challenging ones. These openers, hopefully you guys remember how to do all this stuff. Sometimes people, when they first see this, they think about graphing the line right away. That's not necessary. It involves, a lot of work, creating the graph, plotting it out, takes a lot of time. So I would suggest, remember, what do you know about every x-intercept in the world? You know that every x-intercept has a y value of 0, and every y-intercept has an x value of 0. So we can just do this in our head, right? Let's do the y-intercept first. If the x value is 0, if I put 0 in here, 0 times 12, that becomes 0. 3 times what is negative 6? Negative 2. It's pretty easy, right? The x-intercept, of course, the y has to be 0. That means this goes away, right? If I plug the 0 in. So if I move the negative 6 over, it becomes positive 6 on that side. And x, of course, would have to be 1/2. So remember, don't just default to making a graph. You could make a graph, and don't just say to yourself, oh, I know how to make a graph. I'm just going to do it that way all the time. Because making a graph is just inefficient in that type of problem. It just takes too long, okay? If you haven't yet done so, try to do this next one yourself, okay? But I would use the same technique, but you could pause me right now and do this yourself if you want. X-intercept, y is 0, okay? I'm going to do the y-intercept first. If that's 0, that goes away. 1/2 of what equals 4? That's, of course, 8. X-intercept y is 0, so that goes away. I'm going to move the 4 over, so it becomes negative on that side. Multiply both sides by 4 to get x by itself, and I get negative 16. So there's that. All right. On the bottom here, I'm hoping that you've had, for some of this stuff, you should have had huge exposure, especially the stuff in the middle in the gray, slope-intercept form, point-slope form, standard form. Point-slope form is going to be important. I'm going to be talking about that a lot. It's really helpful. These things on the top, you probably had some kind of different exposure. Certainly slope formula, midpoint formula is very easy. You're just averaging the x's, averaging the y's to find the midpoint between any 2 points. Distance formula, hopefully you've used this. If you've not, it's not as hard as it looks. And I'll kind of talk through this a little bit later, okay? But we're just, taking the difference of the x's, squaring it, difference of the y's, squaring it, adding it together, taking the square root. Okay, we got to remember with equations of vertical lines, it's just going to be x equals some number. So like x equals 5 would be an example of a vertical line equation. Vertical lines, slope are undefined. Horizontal slopes are 0. Parallel lines, of course, same slope. Different y-intercept, you guys knew that. Perpendicular lines have opposite reciprocal slopes. An example, of course, is if we have a slope of, remember, slope is represented by the lowercase m. If we have a slope of 5, the perpendicular slope would be negative 1/5, right? So this is the symbol for perpendicular, upside down capital T. This is a symbol for parallel, okay? And again, as I mentioned, and you guys all know that slope, you see up here, represented by m. All right. Okay, so here's some problems on the back. Maybe I'll end up doing all these, I don't know. Line is a slope of 3. So a lot of times people go to the equation of a line here, I would just use slope formula. So like here's 2 points. There's 1 point, there's the other. To find the slope, what do? We do y2 minus y1. So p minus negative 3 would be p plus 3 over 5 minus 2. Now that equals the slope, but we're given the slope here. So instead of finding it, we already know the slope, we just have to solve for p. Now I'm going to go ahead and cross multiply. Remember, this becomes 3. And if I cross multiply, remember this is really 3 over 1, I'm going to get 9 equals p plus 3. So p, of course, is 6. Remember, there's that invisible 1 underneath that. So that really is the way to go, I think, instead of using equations of lines. But you could use an equation of line as well. Find an equation of the line whose intercepts are twice those of this. Well, using the technique that we did on the front, you should easily be able to determine the x-intercept and the y-intercept of this thing. I'm not going to show that. You can go back and look at the 2 opener problems. This would be 5, 0. This would be 0, 2. Now it says to double them. Well, obviously this is going to be 10, 0, and this would be 0, 4. I hope it makes sense that the slope doesn't change, but we can find the slope now, right? But it's the same as this. The slope here would be 4 minus 0 over 0 minus 10. So that would be negative 2/5. So we have the slope. Now, guys, it just says find an equation. So it doesn't specify what form it has to be in. Okay? So, we could use whatever's easiest. And considering that this point here is 0, 4, that's a special point, right? When you have a 0 first, that means that's the y-intercept. So if you know the y-intercept, in this case it's 4, you want to use a slope-intercept form. So our equation will be y equals negative 2/5 x plus 4. If you didn't know the y-intercept, then using point-slope form is typically easier. Okay? But if you know the y-intercept, go ahead and use slope-intercept form. All right. Now, I know it's been a while. You guys have had my pen stopped working here. Let me see if I can get it working again. Yep, there we go. You have all these all these variables here, and that kind of freaks people out sometimes. All right. It's no big deal. This is just going to be y equals mx plus b. In other words, show that negative a over b is the slope. We just want to solve for y. We want to get y by itself. So we have to subtract ax, and we have to subtract c from both sides. So if we do that, that would be negative ax on that side and negative c on that side. But y is not by itself yet. We still have to divide everything by b. And now y is by itself. And we're done because this is the m. The number in front of the x, that's the m. Negative a over b, that's the slope. This, of course, here, it's not asking for it, but this would be the y-intercept. All right, this next one's harder. We're going to do this, of course, live on Zoom. Find the distance between the lines y equals negative 3x and negative 3x plus 6 and negative 3x plus 1. All right. First of all, you don't have to have a graph, but this first time you're doing a problem like this, I put this graph out here so you can create a visual. Both of these are in slope-intercept form. I hope that you recognize right away that they both have a slope of negative 3. So that means these lines will be parallel. Let's go ahead and graph them. So there's the y-intercept for the first one. A slope of negative 3 means down 3 over 1. Down 3 over 1. I'll just do that a bunch of times. And I'm going to draw a beautiful line. You don't have to take out a ruler or anything. You just freehand it, but best you can. Okay. And now I'm going to do the other one as well. -1. Remember, we know it's parallel, down 3 over 1. And there's a reason why I'm going to go backwards here too. Up 3, left 1, up 3, left 1. And there's a reason why I want to create this visual, especially the first time you do this. So we're asked to find the distance between two lines. And I want you to think about how would you go about doing that, okay? How do you measure the distance between two parallel lines? For example, if I pick a point on the red line, like let's say right here, and I pick a blue line the point on the blue line right there, would I measure, is that the distance between the two lines? I hope you say no, because like measuring from here down to here, that really wouldn't make sense either, right? And I hope you realize that the distance between two parallel lines would be the shortest distance possible, which of course would be the perpendicular in between. Okay, now there's a million different perpendicular lines that you could draw in between here. Infinite, actually. But there's a couple of them that make sense. What would be nice is to use a y-intercept that you already have. For example, you could use this y-intercept and draw a perpendicular. You could use this y-intercept here and draw a perpendicular. So one of those is probably the way to go. Now, I'm going to use this one up here. Now remember, our slope is -3. So the perpendicular slope would have to be positive 1/3, right? The opposite reciprocal. Okay? Now, again, I'm just going to create a visual. So up 1 over 3, down 1 left 3. There is my line. It might not look exactly perpendicular, but yeah, it looks pretty good. That's not bad. Okay? Now, what I have to do, and this is what's tricky now. Well, we have to find the distance from this point, because that's the point on the green line and on the red line, okay, to this one here, wherever the green line crossed the blue line. And see, we don't know. It doesn't cross right there at that blue point. It's a little bit above it. So it's going to be, we need to figure out what that point is. I know that this is 0,6, but I don't know this one. This is going to take a little bit of work. This is a tougher problem. This is a 4-level problem. All right. Now, how are we going to find this point? And I hope you're thinking, hey, wait, I know the equation of this blue line. That's y equals -3x minus 1. I can come up with an equation of this green line, right? I know the slope is 1/3. I know that's the y-intercept. So that would be 1/3 x plus 6. And then, of course, the blue one, which was given to us, was y equals -3x minus 1. If we solve that system of equations, we then know this point of intersection. Once we know that point, then we can use distance formula to finish it up. So I'm going to use my vast system knowledge, do some substitution, right? I'm going to stick -3x minus 1 in for this y, and this is also called setting equations equal to each other, okay? Now we got some fractions here. Don't let that freak you out. Okay, it's not that bad. I'm going to combine my x's. I'm going to add 3x. But remember, adding 3x, that's the same thing as adding 9/3 x. 9/3 and 1/3, of course, would be 10/3. Subtract 6 from both sides. No big deal. Remember, we want to multiply by the reciprocal here, because that's going to get x by itself. Boom, boom. And this looks really bad. It's not as bad as you think. And you don't need to use a calculator. You can do this all in your head. I'm going to kind of help you out with this here. My screen will come back in just a second. There it is. So there, that's the x value. That's the x value of this circled intersection point. I still have to find out the y value. Okay. Let's go ahead. Actually, these numbers are getting a little bit big, so we might need a little calculator to benefit us a little. But here, watch this. In my head, I could plug this into here. Watch this. Negative 21 over 10 times negative 3. Well, a negative times a negative is positive. 3 times 21, of course, is 63. So I have 63 over 10 minus 1. But 63 over 10 minus 10 over 10 would be 53 over 10. So that is my point of intersection. Okay, negative 21 over 10, comma, 53 over 10. And then remember, we knew that the other end, let me fix this a little bit. That was 0, comma 6. So that's what we have to find the distance. We find the distance between those two things and we're all set. So this is distance formula. So just ask yourself, how far apart are these x values on the number line? Obviously, the distance between these two things here would be 21 over 10. We have to square that. Now, I'm not expecting you to be able to square 21 in your head, so don't go ahead and use your calculator there, but 21 squared is 441. 10 squared, of course, is 100. Now, this one looks bad, but watch, it's not. We can do this in our head, actually. So check this out. That's 53 over 10. But 6 is the same thing as 60 over 10. So the difference between 60 over 10 and 53 over 10 is just 7 over 10. And we square that. See, it's not as bad as it looks. Now that, of course, is going to be 490 up top over 100. Now we got to simplify that. We can't leave a radical like that. But the nice thing is, this is the same thing as the square root of 490 over square root of 100. We know that the square root of 100 is just plain old 10. Now square root of 490, we got to break that up. We got to simplify that. That's the same thing as 49 times 10. And of course, the square root of 49 comes out as plain old 7. And shazam. The distance between these two parallel lines is 7 root 10 over 10. Okay? That's a harder problem. You might want to, look at this again. Okay? And there'll be another one on the next page as well. Okay? All right, that's it for now.